Right, today I'm talking to Joshua Kempner, who is Director of Architecture at Perkin Helmer. Trying to say that correctly, as usual, which is not easy for me. And we're going to talk about how to train people into event sourcing. And one thing to note is that you've built a framework slash library, I don't know what you prefer to call it, that helps people with event sourcing, and that's open source, and it's called
Reactive Domain.
Yeah, Reactive Domain. There's even a Slack channel for it. We can put details on the video when it's out.
Sure.
So,
yeah.
Yeah.
Thanks. So I'm Josh. Been at Perkin Elmer for a number of years as Director of Architecture. I've worked mostly in the life sciences business, but Perkin Elmer has a lot of business in a lot of different areas. So I have my fingers in quite a few different businesses. As you've said, we built Reactive Domain a number of years ago, got the company's permission to open source it. It's not really sort of key to our business. It's more the plumbing for doing event sourcing. So we open sourced it. It's might call it a framework, you might call it a toolkit. It was really designed to make event sourcing and message-based architectures easier. It is not the most high performance framework. It wasn't designed for that. It was designed to be easy to use, easy to learn. And it was really kind of built with code reviews in mind. And part of that gets to the training question, right? Which is, as you're training people, code reviews become a really important part of that, right? Seeing code from new developers, reviewing it, finding things that are wrong, correcting them, improving people's ability to write good code from the get-go. And so having a framework that's really built for code reviews helped with that immensely.
That's interesting. What's the thing you are looking for in that kind of code reviews?
Yeah, so
the qualities you're looking after.
Sure. So I mean, it's not necessarily particular things we're looking for, but there are things, for example, all handlers, all event handlers, command handlers, all look the same, right? We use the same pattern for handlers throughout the framework. And so there's, as a result, a very limited set of patterns that a reviewer needs to look for, and things can jump out really obviously if something's wrong. So for example, command handlers all return the same type of response. They all return a command response. And we kind of deliberately from the beginning said that it is not a good idea to subclass command responses. It's possible, right? There are rules like that were made to be broken. But, sort of the default is don't customize your command responses. So every time you see something that says handle and a message type with return value of command response, it's a command handler. Anytime you see a method called handle with a message type in it that returns void, it's an event handler. And the semantics are always the same. So it makes it really easy as a code reviewer to go through and see how a developer has implemented all of those things, identify their handlers easily, see if there's a problem. Oh, look, they're throwing an exception in an event handler. That's a no-no, right? So it makes it very easy to identify simple things like that and sort of straightforward violations of design patterns.
Yeah,
and rules.
I guess it makes also more easy probably to focus in the review on the domain aspect of the content.
Absolutely, yeah. And on the content. So there's boilerplate there, but a lot of the boilerplate gets out of the way. And we did try really hard to abstract as much of the boilerplate as possible into the framework to make things automatic. So for example, correlation and causation IDs are baked into the base type of message. And we use a message builder that uses a builder pattern to build all of the messages, either new root messages or messages that correlate from earlier ones, so that the user doesn't have to think about, am I setting the correlation and causation IDs correctly? How does that all work? It's just, message builder dot from and the original message dot build, and give it a func that returns a new message. Right? So it makes it really easy to do sort of the necessary things for, in this case, for correlation and causation, so that you have all of that infrastructure. You can do the forensics, you can do the message tracing without having to worry about getting it right.
Yeah, or forgetting to
do it. Right.
Yeah.
Right. So there are some other things like that. So for example, there's an aggregate root base class that all aggregates derive from, and everything about the about message correlation on the events that aggregate raises are kind of wrapped into the base class. So the user doesn't have to worry about, did I get it right? They can focus very specifically on the domain logic and not on getting the details of correlation and causation correct. So when they want to raise an event, they just call a raise method, hand it the event, and it raises it, and all of the correlation and causation information is put onto the event silently in the background.
That makes total sense. That's something I forgot always to add to my own little library, because I tend to rewrite them every now and then. So, but I forget that always.
Yeah.
It's like,
and there's always the temptation to do that, right? We're constantly fiddling with reactive domain, but we've tried to keep it fairly stable because it is being used in production by a few different companies.
That's cool, actually. That's really cool. Well, just to maybe to have a full disclosure, I know that Chris Condron also works on that.
Yep. So Chris was really the originator of it. He and I did a lot of the sort of early conceptual design work. He did a huge part of the implementation. In sort of evolving it, he and I have contributed quite a bit to the continued evolution of it. We have new versions coming out relatively regularly, and there's a lot of work going on behind the scenes that doesn't necessarily see the light of day.
The experimentation is part of the trade. Are there kind of other design choices that have been made or to simplify, or to have people fall into the pit of success?
Yeah. So I mean, there are some ways, I guess, in which we made some design choices that make it a little less polished than some other frameworks, but make it relatively easy to use at the same time. So for example, we built in a lot of base classes for implementing ephemeral read models, right? So all of your read models are hot. It doesn't have anything built in for for caching your read models in SQL tables or whatever. But if you want to add that, you can, once you have a demonstrated need for it.
Yep.
Right. So it's not terribly opinionated about those sorts of things. It tends to leave a lot to the developer to add if they want. Some other good examples. Another design decision that we made pretty early on, and which we're starting to revisit, is we decided to make all of our handlers be synchronous rather than async. For a variety of reasons. One of them is, as soon as you go async, you have to kind of go async all the way down.
Yep.
right? And async has a habit of bubbling up into places where you don't necessarily want it to be. But on top of that, if you're taking a user who is used to sort of a traditional three-tier architecture, rich object-oriented hierarchy, um, going from that to a message-based architecture, which reactive domain also helps support, is a bit of a leap, right? Conceptually, it's harder to follow. Debugging a message-based architecture, especially when handlers are asynchronous, can get really tricky, right?
Yep.
So by making everything synchronous, it makes the debugging process easier for people to learn. There are, of course, ways that you can, any handler, you can spin off a thread and do processing asynchronously and return from it. But by default, things are fully synchronous. It also helps avoid thread pool starvation when you're dealing with high volume scenarios where you have a ton of events coming in. One of the early adopters of reactive domain was a fintech company, and they're dealing with huge amounts of events in a trading application, right?
Yep.
So in that sort of scenario, you can get thread pool starvation very, very quickly and easily if you're not careful. So making everything synchronous, simplifies that.
You make it. Is there some kind of in-memory queuing in there?
Yeah, so we have sort of this kind of the standard bus queue, chained together as needed to handle that. So yes, we can, you can take events, drop them in a queue, return, and then process the queue one at a time later if you want to, sort of a standard SATA type architecture.
Yep. I'm asking that because internally, event store is also tries to use as little thread as possible. Or there's a lot that happens on same thread, and
yes,
it's actually astonishing how the type of volumes and rates of processing that you can get in such an architecture tend to always go, okay, we need async, we need threads, and sometimes it just pay a little more attention how you build it, and you will get a lot without headaches, or with
absolutely.
less headaches.
Yes,
So
yes, for sure. Yeah, a lot of where we tend to use multi-threading is more on long-running jobs than on sort of, parallel high volume scenarios. So yeah, that's definitely a consistent thread throughout, no pun intended. One other thing that I think is worth mentioning, also kind of on the handler front, one of the things that reactive domain does, which I think is fairly unusual, is in command handlers in particular, the message bus or dispatcher automatically wraps exceptions that are thrown in handlers and sticks them back onto a failure type of command response. What that means is you can write really simple code that's just, if something goes wrong in your command handler, just throw an exception. You don't need to worry about how do I need to wrap that into a response that then, the sender of the command can handle properly. Just throw, and the bus will wrap it up and send it back to the to the dispatcher.
It's a specific response type then.
Yeah, so there's the command response is the base type, and there are command succeeded, command failed, and command canceled types that subclass from that, and it just wraps it into a failure response.
Yeah, it boils down to actually what you would do in functional programming, where you could have different some kind of union tab, but in .NET in C# in object-oriented kind of scenario. Yeah,
Right. And again, the sort of built for code review, It makes code reviews a lot easier if you don't have all of this boilerplate wrapped around dealing with command response types. It's very simple, straightforward code. If something goes wrong, you throw an exception and forget about it. So
probably makes it easily testable as well.
yes, extremely.
In isolation, I mean, no?
Right. Yes. So in unit tests, if you have a scenario that you want to test where you want to test a failure scenario, you can just assert that, and we have a number of extensions to the assert library for unit tests. You can assert that the command throws a particular inner exception type, and it makes it very easy. Yeah.
And any other design choices made to make things simpler?
Sure.
Simpler is maybe not the right word, but more accessible.
More accessible. Yeah, sure. Trying to think what else. So, I mean, one of the things that I've hinted at but haven't made really explicit is it's not just an event sourcing architecture. It also helps implement SATA, an event-driven architecture.
Yep.
And because the types of events in an event-driven architecture and the events in event streaming or event sourcing are really polymorphic, we take full advantage of that, right? Mm-hmm. So an event looks the same whether you're defining it to be something that gets raised on an aggregate or a transient event that is going over a bus for some runtime piece of functionality. So again, everything looks the same, right? All of your event handlers look the same, whether they're dealing with events from an aggregate or events coming in on a bus. Yeah. So in read models, for example, whether you have a read model that's handling transient events or a read model that's playing back a stream, they all look more or less the same.
Yep.
Because they all have the same, the event handlers all look the same. They do the same sort of things. The only thing that's different is the semantics of what the source of events is that you're subscribing to. Are you subscribing to a stream or are you subscribing to a bus?
Okay, that's explicit then, because that would have been my question. Do especially newcomers, because I guess from what I understood, you have people coming in and let's be honest, there's not a lot of people who are familiar with events with message-based
Right.
system, and even less with event-sourced systems.
Right.
That they don't get confusion between, actually I'm inside doing work inside an entity, an aggregate, mm-hmm. which needs to build up state in a certain way with true handlers, or mm-hmm. I'm building up a read model which is mechanically the same, but serves a different purpose, and where you probably make some kind of little differences or some ephemeral events. So how do you help them, making the difference, the type of
right. Yeah. So within aggregates, they do look substantially different. Mm-hmm. The semantics for handlers inside aggregates are quite different from the semantics in read models, mm-hmm. Or in other services. So no one is ever going to mistake one for the other. And so within an aggregate, and this was actually a design choice that we made along the way after kind of seeing how people use it. When we started out with reactive domain, we said every kind of event that gets raised on an aggregate must register a handler for the event, even if it's an empty handler. Mm-hmm. Just to be really explicit about all of the things that a handler or that an aggregate needs to deal with. What we found after a while was it resulted in a lot of noise within the code, right? You had all of these empty handlers that, and there was a tendency among people who were new to event sourcing to say, oh, well, why I shouldn't really have an empty handler, right? An empty handler looks like I must have missed something. So let me put something in there and add some state to the aggregate. But then they never do anything with that state, right?
Yep.
And the fundamental principle is you don't add state to your aggregate unless you're going to use it for decision making in the future, right?
Yep.
So we walked back that and made a different decision and said, registered handlers are completely optional.
No.
And the end result of that is the code is much cleaner. You have a very small number of registered handlers within your aggregate. And it makes it really clear that the only time you bother to handle an event that gets raised on that aggregate is when you absolutely need that data in order to be able to make a decision.
Yep. That's something I've noticed also, that sometimes you raise events in entities, nothing to do with reactive domain, but on the topic is sometimes you raise event with information in, and it kind of bother people that sometimes you put information in that event that you're not going to read back afterwards,
right,
because you don't need it for the next decision, but you need to register the fact that you had this decision and this is the information that's important. It's kind of annoying people new to it, like,
right,
why am I saving that if I'm not reusing it inside
right, right.
now or later? Yeah, but we're going to use that at in totally different part of the system.
Exactly. Yes. Yes. Some read model somewhere is going to want that.
Yeah.
So
And
yeah, I mean, a prime example of that is audit trails, right?
yep.
If you want to have a complete auditable history, you'd better be saving everything, whether you need it for decision making or not.
Yep.
So,
Yeah. Or the result of the decision, but that kind of body people, like that some invariants are not. I mean, the yeah, the total information in all the events of a specific stream, let's say, is not necessarily the one you need to make the next decision.
Right. Right. Yeah. Absolutely.
But still important captured information
Mm-hmm.
on that subject. So you use that library in at work. So you need to train people in that, and
yeah. So when we're training people, we have sort of a consistent, very simple training program that we run people through. We've had some slight variations on it over the years, but it's a basic sort of bank balance application, right? Just very simple. You only have two actions, debit and credit. It's purely a console app, right? It's something that everyone's familiar with, and the way we go about the training is we tell people, for starters, build an application. Forget about event sourcing, right? Just before we teach them anything, build a small console application that doesn't need to persist anything, doesn't need to save data from one session to the next. Just build something where you can type in a credit and a debit and it'll keep a running track of your balance.
Yep.
And people do that, and it's usually a handful of lines, one file, program.cs, and it's very simple. And then we start getting them into the idea that each of these things that they're doing is an event, right? And okay, now they can persist these. So we start them out with, okay, learn how the aggregate based class works. Build an aggregate, put simple debit and credit events on it. No special rules or anything, just everything always succeeds, and tell me what the balance is at the end. We build that up over time, over the course of a couple of weeks, 3-4 different versions, putting in things like logic to refuse a debit if it would make your balance negative, or have some limit on overdraft, and so on. We teach them the full CQRS sort of loop of command, event, read model, and view. And after a week or two, they've built this simple application. And are usually fairly comfortable with the concepts at that point.
Yep.
We don't try to do anything with a GUI, right? It's all just command line, because really we want the focus to be on the stuff that goes on under the hood.
Yeah, the general note, command lines are undervalued in a large part of this industry. It's really powerful. You don't have to take, I mean, oh, UI,
Right,
oh
right. No, they don't
yeah.
have to worry about setting up a web server or a WPF UI or whatever. Just do it. Just
Yep.
it's very simple at the command line.
So I guess you can go with that kind of training. You can go also do a bit of modeling, because even the bank accounts. I mean,
Absolutely.
you could do it ledger based. So every moves in one stream, then have read models for
Yep.
the balances themselves, or go into more fine grained. I mean, the different options. So you go over all those options and
Mhm.
how to model them then and
Right, right.
implement them.
Yeah, you can make it as complicated as you want. It
Mm,
depends on how deep you want to go and what you want to what the focus of the training is really.
yep.
Um,
And that's cool. And then maybe one more question. How did reactive domain evolve over the time, and what's kind of the future, or what
yeah.
where do you want to get it? I'm
So
asking difficult
yeah,
questions. Sorry.
no, that it's good. So Chris and I have already started talking about reactive domain too, and we have some ideas. Where it started was actually from two places. So it started from sort of core business requirements, right? Knowing we knew that we needed something like event sourcing to be able to support some of the business requirements, in particular around audit and history and sort of the things that event sourcing excels at. We also knew that we needed an event-driven system because we were building a product that had components running on multiple different computers. One of them connected to an instrument, one running on a tablet, and we needed to be able to sort of stand up different parts of the user interface on different devices, and have and show the different parts of the UI in different places depending on how we bootstrap things.
Yep.
And so an event-driven architecture was sort of natural for that. This was long enough ago that there weren't a whole lot of open source options out there.
Mm-hmm.
A lot of the the messaging frameworks and things that are out there today were quite a bit less mature then.
Mm-hmm.
We pretty quickly built something on our own just to get ourselves up and running. It worked well enough, and so we kind of kept it going.
Yep.
And it a big part of it then was, and this is still a big part of it today, is kind of keeping the plumbing separate from the code, right?
Mm-hmm.
We wanted reactive domain to be the plumbing that you don't have to think about, right?
Yep.
So things like wrappers around event store connections, and we've continued to evolve that and make that even a little bit more sort of abstracted, so that you can say, here, connect to this event store, create all of the, set up how you're going to serialize your events and your prefixes and your naming conventions and all of that. And then we just sort of wrap all of that up. And anytime you need to get a stream, for example, the user doesn't need to know anything about what the stream name is. They just say, for this connection and this type of aggregate, get me the stream.
Yep.
And it will figure out the naming convention and all of that. So we started out, I think it started out being a little bit less abstracted, and we have gone further and further down the road over time of abstracting that stuff away and making it higher and higher level.
Mm-hmm.
I think that's probably the future of reactive domain as well, is to continue with that sort of thing. More things to sort of make it difficult for people to mess up.
Yep.
So, for example, I mentioned the message builder to put correlation and causation information on your messages. We've built a bus connector that enforces that.
Yep.
So if you try and put an event on the bus or a command on the bus that doesn't use that builder, doesn't have the correlation and causation information, you'll get an exception. Yep. Instantly, right? It's these are the sorts of things that can prevent developers from messing up early.
Yep. And those come, I think, probably from real life usage and things that people. So that's the way it evolves. And
yeah, very much. It's very much a framework that is kind of production extracted, right? It's not a theoretical framework. It wasn't built to sort of model some theoretical, I don't know, some theoretical model of how an event source system should work. This is what we're doing. This is the stuff we need to do. Let's build a framework that does exactly the things we need.
I'm going to correct you because you said it. Let's extract it from what we've built to, because you said extracted. I like that word.
Yeah.
To extract it from real usage and let that evolve.
Yeah, I have to give Chris full credit for that one.
I guess we have to give credit to Chris for a lot of things.
Yes, absolutely. So
I think if you have something else you want to say, that's the moment, I think, because we're almost end of our time. So
no, I think that's about it. I mean, I could talk a lot more about reactive domain, but I think we've kind of hit the highlights. And I'm really looking forward to version 2. As I said, Chris and I have started talking about some of the things we want to do, some things we want to improve.
Sneak peek. No, you can't. Okay.
Yeah, it's anything I said would probably be wrong once we actually get around to implementing it. So, yeah.
That's event sourcing. If you do something wrong, it's going to get recorded, and you can reflect on it later on. Then.
Yeah.
So
we're currently working on some pieces to allow for authentication and identity on built into the framework. In part, it's going to be really useful for people who are using it for audit trails to be able to keep identity information, but then also it's being built into the dispatcher. So we're building in a mechanism to be able to essentially authorize commands or authorize users to issue commands, and have, again, a bus connector that will check for user authorization on a command-by-command basis and refuse them before they even get to the handler.
Inside the pipeline, then. Yeah, that's cool.
Yeah.
That's useful thing, because just from the moment you have users and so on, you need to do some authorization and so on. But it's hard to get right.
Yes, it is. It's been a slow process to develop that, but we're getting very close.
That's cool. That's really a nice functionality if you can get that in, and if I give my 2 cents in an optional way, that you can.
Yes, very much.
On or off for different scenarios. Then
exactly, and we've tried to take that philosophy with most things. So you don't have to use a correlated bus, for example. If you want to use messages without any correlation and causation information on them, go for it.
Yep.
The framework.
Okay, so you have options there. But once you say I want correlation, it's going to get enforced. And that's cool. That's
exactly.
that's really nice.
Yeah.
Um, yeah, we're out of time,
All right.
unfortunately,
Well, this has been a
already.
pleasure.
Yeah, thanks a lot for your time, Joshua. And yeah, as soon as version 2 is out, or even a better idea, you know what we should do? We should have you and Chris record it while they discuss those functionality, because
Sounds
that
good.
might be an interesting process as well, to see in action.
That would be great.
Yeah, thanks a lot,
All right.
Joshua, and see you around.
Thanks. Bye.